Hello students, today we will learn the lesson work and energy. Now, what do you mean by work? Your father goes to work, he goes to job. Your mother is cooking in the kitchen, she is also doing work. You come to school and you do your classwork and you go back home and you do homework. You use the word work. Now, is that the same work in physics also? Let us see. How do you define work? For example, I take an object, right? This is the duster. When the duster, how is the duster? It is in the state of rest. Now, I apply a force on this body. When I apply a force on this body, the body is moving. That is a displacement. Then, in physics, we will say work is done. So, work is done in physics when you apply a force and there is a displacement S. We use the symbol displacement S or distance because it is an old term called spatium. It has come from space. Okay, it has come from that spatium. That's why we use S very often rather than D as a displacement. So, when I take, for example, let me draw a surface now. Okay, I am drawing a surface now and I am going to take an object, let me say a box I am taking, fine. And this box is going to move from one point to another, right? I am not worried about anything. I am just applying a force on this body. When a force is applied on this body, the body is going to move and it is moving in a straight line, fine. And the body comes to this position, let us say, right? So let me just check it little carefully, fine, yes, the body is coming to this position. Yeah, let me just draw little bit with the preciseness. Physics is all about preciseness, right? Physics is all about measurement. Okay, without measurement, the things will not be proper. Fine. So the body has come. So what is the displacement taken place? It is S from this middle point to this middle point. So work done is equal to force into displacement. Now what is force? What is the unit of force? That is Newton. Newton, you write it in capital N but in the letter small. And displacement or distance is in meter, which is the SI unit, standard international or international standard unit. So the unit is Newton into meter. Let me do a simple problem now. Suppose I apply a force of 100 Newton, right? And the body is going to displace by 8 meter. Then what will be the work done? Very simple. Force is equal to 100 multiplied by displacement is 8, that is 800. Now Newton meter. Newton meter together is called by a name, scientist name, that is James Prescott Joule. So this is called Joule, Joule. But you will write it again in capital letter. The term should be written in capital letter. So the work done is 800 joule. So this is the answer. So in physics, when you say work is done, two conditions have to be fulfilled. One is there should be a force applied. One, you have to apply a force, and point number two, there should be a displacement of the body. If these two things does not take place, then work is not done. Now for example, let me take an example here. Yeah. See, for example, I say that I am going to push an object. Yes. What is force actually? Force is a push or a pull. It can be any one of them. Fine. Now, I am going to take a wall, a big wall, right, which is perfectly fixed on the ground. Now, I stand here and I am going to push this wall. If someone is pushing the wall, yes, of course, he is applying a force. Force is being applied. But can he move this wall? No. As long as he cannot move the wall, then there is no displacement, then the work done also will be equal to 0. You have to remember this. Force is applied, but there is no displacement. So that means work is 0. I can give you another example. For example, I take this body, right, and throw it up. I apply the force and I take it back. When the body goes up and comes back to me, see, now this is what is going to happen. I throw the chalk piece up and it comes back. Now I applied the force. I applied a upward force. But again, what is the displacement? Again, it has come back to the same point. So that means work done is 0. I give you another example. Here, you take for example a circle. In the case of a circle, if there is a body here, right, and I am going to think the body in the circle. I am going to move the body, whirl it, right, and the body is moving like this. If at the point A, the body goes in the circle and comes back to the point A, that means the displacement is 0, but there is a force applied, but the work done is 0. An object which is in the circular motion, if it comes back to the same point, work done is 0. Now I have given you all the examples where the work done can become 0 also. Now we will discuss about some cases of work. Fine. It's a very simple logic. Okay. There is a surface, horizontal surface, and there is a body, and a force is being applied. Now the body is getting displaced, right? This I am drawing you for rough surface, rough sketch. Okay, the body is coming here and displacement is S. Now see carefully, the force applied and the displacement, or both of them are in the same direction. Then you are having the formula W is equal to F into S. In later, you will come across a point called cos theta, trigonometric functions. What will happen? Really, W is equal to F into S is a simple formula, but they will introduce a term called cos theta, which is a trigonometric function. In trigonometry, there are basic 3 functions: sin theta, cos theta, and tan theta, which you will learn in your mathematics course, most probably in 10th standard. But without going deep into it, I will give you a simple way. I will explain it. Now this theta is the angle. The word is theta. The theta is the angle. Now look carefully. This is the force applied and this is the displacement. If I bring both of them together, you see, force and displacement, they both are in the same direction. So there is no angle at all. That is, theta is equal to 0. When theta is 0, this cos value, this will become cos 0 degree. Cos 0 is equal to 1. So you will have work done is equal to force into displacement. Do not worry too much about it, right? And I will tell you why you don't need that much to worry, right? So theta, I introduced this formula for you. Okay. Now suppose the displacement is here, but I don't apply the force in this way, I apply it in an angle. This is the force applied and this is the displacement, and this is the angle theta. Now, when the force and displacement, they both were in the same direction, we said theta will naturally become 0. So which implies cos 0, that is equal to 1. So work done is equal to Fs cos theta, which became W is equal to F into S. So this is fine. Now, if suppose, where do you find this kind of things? For example, you will find that, for example, when there is a toy, you will find that children will not pull it like this. Children will hold the string and pull it. That means they are pulling it at an angle. When they pull it, for example, you take in the cricket field and you have got a roller in the middle. They will not push the roller like this or pull the roller like this. They will pull it at an angle. So when they pull it at an angle, the force applied and the displacement will have an angle. When there is an angle, you have to account for that angle. What is the degree? That you have to account. That's why there is a term called cos theta has come here, that you will learn in senior classes. This is an introduction for you. Right. Suppose if I take a body and the force is perpendicular, let us say F is perpendicular. Now how can it happen? For example, I take a bucket of water and I walk like this, right? Carrying a bucket of water. Water is having weight, that means it will act downward direction, right? W is equal to mass into gravity, you know, mg, and displacement is in the horizontal direction, which implies that the angle is 90 degree. If the angle is at 90 degree, theta is equal to 90 degree, then cos 90 degree, which is equal to 0, which implies work done is 0. You know, that was the reason in circular motion, at the center here, you apply a force like this, force is like this, and the displacement is in the other direction. So there also you can apply the same formula. In the higher classes, 11th you will learn more about it. In 9th standard, you can learn basic of it. Now, I am going to take a very special case. I apply a force in the opposite direction. This is the force direction and displacement is opposite. Then what is the angle? You take a straight line and this is the axis. This is 90 degree. This is 90 degree. Fine. Now in the straight line, I am going to take here in the straight line. This is coming from here to here. So 90 plus 90, 180 degree. Displacement is like this and force is like this. They are opposite to each other. Then theta is equal to 180 degree, which implies cos 180 degree, which is equal to minus 1. If cos 0 is this side, which is 1, when I go opposite direction, it will become minus 1, and the middle it was 0. It is just like your number line. In your number line, you have positive direction, you have negative direction, and the middle point is reference point to 0. Just like that, it happens for cos theta. Only for cos theta, you have to keep it in mind. Okay, don't get confused. Later in trigonometry, you will learn more about it. If it is minus 1, then the work done is minus F into S. Why there is a negative sign? That means work done is negative. How can the work you do is negative? That means this work is positive. If this work is positive and this work is negative, how can work be negative? You do work, how can that be negative? In physics, it is not possible, and I will give you an example why it should be like this, in which case you will find that both of them are opposite to each other. You know, in olden days, you will find that people had well. Now also in villages, you have well in which water is there. And you will find that using a pulley, there is a pulley here, fine. And what happens, you allow a bucket of water, you want to fetch a bucket of water, what do? You put it like this, and the other string is like this. And a person stands here and the person is going to pull this string. As you pull the string like this, that is the force you apply, which is in the downward direction, and the object is going, displacement is in the opposite direction. Where the force and displacement are in the opposite direction. In such cases, we call work is work. Always work is positive, but we give a physical significance to it that we say it is negative. But there is no negative work. Work is there. Always people do the work. That work is done, but it is in opposite direction. So the negative sign shows you only the direction. It tells you the direction. That's why it is called negative work. I also can give you one more example, right? And I think that will help you. If people live in hill areas, let us say, suppose we live in hill area, I have drawn a mountain for you. Let us say, even if it is a slope, and we have a pram in which you put child in it, or you take, for example, an object like this, is having wheels in it, and there is a hole in it, and a person is holding, mother, father, anybody is holding it like this. Watch carefully here. The body is going in downward direction. Displacement is in the downward direction. That is because gravity is acting in the downward direction. And the baby is having a mass. So mass into gravity, weight is pulling it down. Now think carefully. Should the father or mother push the cart or pull it? If they push it, what will happen? The cart will go faster and they will roll down and fall down. So it is advisable. So naturally they will pull it upward direction. The force is applied in the opposite direction and the displacement is in the downward direction. So we can say that work is done. Force multiplied by displacement is work. Work is done. But the cos theta turning to be -1, we say negative. The negative side only symbolizes the force and displacement are in the opposite direction. So, unit of force, ultimately you should remember, it is joule, capital J. And in the next video, we will study about energy and how the work and energy are interrelated to each other in the next video. Thank you so much.